Hello everyone, and welcome back to the VT Tech project. Last time I said I was going to go off and figure out a self-centering control mechanism and a blinking or winking mechanism for the eyes. So I did. And as you can see from this version of the model, I went some places, and it all got a bit overcomplicated. This thing here is a universal joint. It can pivot on the X and Z axis and can rotate around the Y. They used mostly a machinery to transfer rotation between shafts that aren't perfectly aligned, like in a rear-wheel drive car. This one, however, was being used purely because this bar doesn't stay flat when the eyes move up and down. It tilts back and forth depending on the orientation. See how that's tilting? The bar's center point also moves left and right depending on which direction the eyes are looking, and I really needed the shaft connecting to the bar to stay mostly straight and level while also being able to move the control bar. So yeah, universal joint. I did actually print it off, and it does work, but it snapped during testing, so had I continued to use it, I would have had to have beefed up these rings here. This central hub connected to these 4 springs would stretch and compress depending on which direction the hub was pulled in, and then, being springs, would automatically return to their original resting state. I printed that off and assembled it as well. And it worked. Not flawlessly, but it did work. So at that point I could move the eyes all around and return them to center again. All I needed to do was implement some means of controlling the mechanism. Which is where things started going off the rails. These springs need quite a bit of force to move them, and obviously they need to be pulled relatively straight. So my first thought was to use the same bike brake cables I used when I made the original Cable Tech back in 2023. Unfortunately, when I bought them, I didn't research properly. You see, how these Bowden cables work is that there's a metal cable running through an outer sheath that is usually made of, to quote Wikipedia, a longitudinally incompressible layer such as a helical winding or a sheath of steel wire, and a protective outer covering. The cable and the sheath act together to keep the cable travelling along its desired course and transmit the push or pull force required. Past Dan thought the outer sheath was just there to keep the cable on course, and so, instead of buying proper cables and sheaths, he bought cables and 3 meters of fish tank airline tube. Which, when the tube is mostly straight, works quite well. But when it gets curved beyond a certain point, the cable binds horribly and refuses to move. And in the limited space inside Tech's head, there were some pretty tight curves needed that just weren't going to happen. So I went back to the drawing board and ripped out all the complicated parts in favour of a simpler, more elegant solution. My middle finger. Yeah, turns out all I really needed was a little thimble-like thing for my finger to go into, and he could look up and down and all around. So with that sorted out, I moved on to the blink mechanism, which I'd managed to make difficult for myself by the simple act of giving Tech 2 eyelids per eye. Most of the blink mechs I've seen online use a system of having one large eyelid per eye that rotates down over the eyeball using a simple lever. I mean, if you look at some of the animatronics from Chuck E. Cheese and Showbiz Pizza, they use a similar mechanism. It's a good system, it looks good, and it's easy to automate. Next time I design a puppet, unless there's a very good reason not to, I'll be using that system. But I'd already spent hours and hours designing and printing what we have, so I decided to make it work, and this is what I came up with. 2 support pillars with spring mounting points on them that attach to the rings I pre-installed on the eyelids. I measured all that out so the springs would always return them to a 45-degree rotation. That was the easy bit. Then I had to get some kind of control system installed, and that meant running 4 cables of some kind over different distances in such a way that they didn't interfere with each other, and all met at a single point that could be controlled by my index finger. This turned out to be no fun at all. During this process, I realised that I needed a guide point opposite the eyelid mounting holes so the strings would be pulling perpendicular to the eyelid's axis of rotation. And that meant either gluing a separate piece to the already printed eye plate, which risked breaking off under load, or modelling the guides into the eye plate and then reprinting it, which, considering the eye plate took 17 and a bit hours to print, wasn't high on my list of viable options. Luckily, I had some of these wire terminals in my assorted parts tub, and with the delicate application of a soldering iron, I melted some little holes into the existing faceplate, slotted in the terminals, and then secured them in place with UV resin. After that, it was a case of modelling a guide structure to redirect the cables coming off of each eyelid to where they ultimately needed to be, while also keeping them separated, which is where these round splitter pieces come in. And then all those strings come together into a control ring, which was also a bit of a pain to secure because each string needed to stay taut with the control ring right up against the mechanism housing. But UV resin swooped in and saved the day again. And here he is. He can now look all around and blink. There's still a couple of niggles here and there. I might make the thimble thing a bit deeper so it covers more of my finger. Do I see it breaking in future? Who knows? I'm not an engineer. Will the nylon cord I used cut into the guides over time and reduce the line tension, for instance? Not a clue. But for now at least, it works, and I can move on to figuring out his jaw mechanism. So yeah, look forward to that if you're enjoying this little series. Thank you all very much for watching. Subscribe if you're not already, and I will see you in the next one. Bye guys.